Basargaon, Assistant Professor, Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. In this video, we are going to discuss Laplace transform part 1. Learning outcome. At the end of this session, students will be able to find Laplace transform of the given function by definition. Now, we will see the definition of Laplace transform. If f of t is a function of t satisfying certain conditions, then the definite integration from 0 to infinity e raised to minus st f of t dt, if it exists, is called Laplace transform of f of t, and it is written as L of f of t. Here L is the Laplace transform operator. Thus, Laplace transform of f of t equal to integration from 0 to infinity e raised to minus st f of t dt. By using this definition, we can find the Laplace transform of the given function f of t. Now, before finding the Laplace transform of the given function, first we will see very important rule called generalized rule of integration by part. Frequently, we have to make use of this rule when finding the Laplace transform. If u and v are two functions, here in the formula dashes denotes the derivatives and suffixes denote the integrals, then integration of u v dx, where u v is algebraic, that to take as a function 1, then v function with known integral, that to take as a function 2, is equal to u into v1 minus, now you write down the derivative of u, that to denote as u dash, and integration of v1 means we are denoting v2, plus u double dash means second derivative of u, v3, minus u triple dash into v4, and so on. In words, rule states that to find the integration of product of two functions, integral is equal to first term into integral of the second term, then minus sign, then write the derivative of the first term into integral of the second term, and repeat the procedure taking alternatively positive and negative. Now we will find the Laplace transform of f of t, where f of t is here t for 0 is less than t is less than 3, and f of t is 6 when t is greater than 3. Now here given function is f of t equal to t for 0 is less than t is less than 3, and f of t is 6 when t is greater than 3. That by definition, L of f of t equal to integration from 0 to infinity e raised to minus st f of t dt. Here we are making use of the property integration from a to b f of e raised to minus integration from a to b f of t dt equal to integration from a to c f of dt plus integration from c to b f of t dt. Using that, we can write, first we will take the limit 0 to 3 e raised to minus st f of t dt. Now here second integration from 3 to infinity e raised to minus st f of t dt, because here 3 is less than t is less than infinity means 3 to infinity, which is equal to integration from 0 to 3 e raised to minus st, and here f of t in the interval 0 to 3 is t, plus integration from 3 to infinity e raised to minus st, and here f of t is 6. Now here we are making use of product rule, that is generalized rule of integration by part, taking t as a first term and e raised to minus st as a second term, which is equal to, first we will write first term as it is, and integration of second term is e raised to minus st upon minus s, minus sign, that is sign of the rule, into derivative of the first term means derivative of t is 1, and integration of e raised to minus st by minus s is e raised to minus st by minus s into minus s. limit 0 to 3 plus 6, we can take constant outside, and integration of e raised to minus st is e raised to minus st upon minus s with the limit 3 to infinity. Now we put the limit which is equal to, first we put the upper limit, that we will put t equal to 3 here, then e raised to minus 3 s upon minus s minus e raised to minus 3s upon minus s into minus s, then minus of lower limit. Here we get 0, because here if you put t equal to 0, first term will become 0, then minus sign, and here we know e raised to 0, we get e raised to 0 is 1, that we can write minus of 1 upon minus s plus 6 into, here we know we are putting the upper limit e raised to minus infinity, as t tends to infinity, e raised to minus st tends to 0, which is equal to 0 minus e raised to minus 3s upon minus s, that is 3 into minus 3 into e raised to minus 3s upon s minus e raised to minus 3s upon minus s into minus s square, then this minus minus plus 1 upon minus s into minus s, that is s square, then this minus into minus plus 6 e raised to minus 3s upon s. Once again we will write here, which is equal to minus 3 into e raised to minus 3s upon s minus e raised to minus 3s upon s square plus 1 upon s square plus 6 into e raised to minus 3s upon s, which is equal to minus 3 e raised to minus 3s upon s plus 6 into e raised to minus 3s upon s, we can write 3 e raised to minus 3s upon s minus e raised to minus 3s upon s square plus 1 upon s square. Again further simplifying, we get which is equal to e raised to minus 3s upon s, 3 will remain, minus 1 upon s plus 1 upon s square, which is the Laplace transform of the given function. Therefore Laplace transform of f of t is e raised to minus 3s by s into bracket 3 minus 1 upon s plus 1 upon s square. Now pause the video for a while and find the Laplace transform of f of t, where f of t equal to 3 when 0 is less than t is less than 5, and f of t is 0 when t is greater than 5. I hope you have completed. Now here, by definition of Laplace transform, L of f of t is integration from 0 to infinity e raised to minus st f of t dt, which is equal to, here first limits are from 0 to 5 e raised to minus st f of t dt plus integration from 5 to infinity, t greater than 5 means 5 to infinity e raised to minus st f of t dt, which is equal to integration from 0 to 5 e raised to minus st, and here f of t is 3 in the limit 0 to 5, that is e raised to minus st plus 3 into 3 dt plus integration from 5 to infinity e raised to minus st, and when t is greater than 5 f of t is 0. Now directly we can integrate, keeping 3 as it is, and integration of e raised to minus st is e raised to minus st upon minus s with the limit 0 to 3, which is equal to, put upper limit 3 by s minus into minus e raised to minus 3s plus 1, which is equal to, by simplifying we can write 3 by s 1 minus e raised to minus 3s. Now we will see one more example. Find the Laplace transform of f of t, where f of t is cos of t minus alpha when t is greater than alpha, and f of t is 0 when t is less than alpha. Solution. By definition of Laplace transform of f of t is equal to integration from 0 to infinity e raised to minus st f of t dt. Again by using the property of definite integral, integration from a to b f of t dt is equal to integration from a to c f of t dt plus integration from c to b f of t dt. Therefore, and here t greater than or equal to alpha means alpha is less than t is less than infinity, and this one is 0 is less than t is alpha, and using that we can write, first we will take the limit integration from 0 to alpha e raised to minus st f of t dt plus integration from alpha to infinity e raised to minus st f of t dt, which is equal to integration from 0 to alpha e raised to minus st, and in the interval 0 to alpha f of t is 0 plus integration from alpha to infinity e raised to minus st, and in this case f of t is cos of t minus alpha dt, which is equal to first value of the integral is 0, integration from alpha to infinity e raised to minus st cos of t minus alpha dt. Now here we can integrate integration from alpha to infinity e raised to minus st cos of t minus alpha dt is equal to, here we are making use of the formula integration from c to d e raised to ax cos bx plus c dx is equal to, we know, e raised to ax upon a square plus b square into a cos bx plus c plus b sin bx plus c with the limit c to d. Now here a is minus s and b is 1 and c is minus alpha. Using that we can write e raised to minus st upon here minus s whole square plus 1 square into bracket, here a is minus s, that is minus s cos of t minus alpha plus 1 because here b is 1 into sin of t minus alpha with the limit alpha to infinity. Therefore L of f of t is equal to, here we know e raised to minus infinity as 0, therefore if you put the upper limit in this integrand, what we get, 0 minus of lower limit, that is we are putting alpha e raised to minus s alpha upon s square plus 1 into bracket, we get minus s cos of t minus alpha means cos of alpha minus alpha, that is cos of 0 plus sin of 0, which is equal to, we get here is minus minus plus s upon s square plus 1 into e raised to minus s alpha because cos 0 is 1 and sin 0 is 0. Thank you. References Higher Engineering Mathematics by Dr. B.S. Grewal.